Yeah, hi there. In this tutorial, we are going to cover missing values in pandas. So to start with, I'm importing pandas and numpy libraries and creating a series S, initializing it with values 11, 21, np.9 and none. So once I print this series S, if you see the data type, D type is float 64. What it indicates as the elements of this series are of float type. Even though none of the elements is actually float at the time of initialization, but still the data type is coming as float 64. The reason being this np.9, this is treated as this is actually a float type. If I check type of np.9, it says float, and the default method of handling a missing value in pandas is np.9. So this none also gets converted into nan. So that is the reason why the data type is coming as float 64 and the series is created. There is a function dot is a name. So using this function, we can find out whether a particular element of a given series is null or not. So what we have to do is s dot is any, and it will return true or false corresponding to each element depending whether it is null or not. If it is null, it will return true; otherwise, it will return false. Similarly, for dot is nl function. Now, if we want, we can avoid this upcasting of data type to float. At the time of creation of a series, what we have to specify is the data type. That is d type is equal to pd.int16 d type or int32 or int64 d type. So this is available from pandas 1.0 version. That is, we can create missing values as na instead of actually null or nan. So this will create the same series 1130. Now these missing values np.9 and none are actually coming as na, and if you see the data type is int16. So this is not getting upcasted to float. So this new representation of missing values as na actually is available in pandas 1.0 onwards. Now on the same series, I can apply .isName function and find out whether any given element is null or not. So accordingly, it will return false or true. If it is not null, it will say false. If it is null, it will say true. So this is fine. I mean, this is just the basic before we actually proceed towards the main example. Now, when we are reading data from a file, there are situations in which missing data is present in a different of ways. It could be, let's say, any column is having a missing value. It could be represented as either as question mark or dash or some word like nan or unavailable or na, things like that. So it is very much possible that within a same file we will have a different ways in which missing data is represented in different columns. So let's say I'm reading one sample file. It's just a very small file with three records. This is what I'm printing here, these three records. So what is important here is to see in these records, uh, age variable has question mark in it. It means this is the missing data. Then there is another second record which is in which age variable has value as nan. Now location is having value as dash, any or unavailable. So these are all actually missing data which is in the data file, but there is no consistency. If you see somewhere it's question mark, somewhere it's dash, any, unavailable, and so on. Now from our perspective, we have to read the data and we have to treat all these things as missing values. So how do we do this? So first of all, we create a list of missing values based on the data. So what I observed that the missing data is could be represented as a question mark or dash or nan or na or unavailable. So I created a list of all these possible values which are actually represented as missing, and so this is stored in this list missing underscore values. Now at the time of reading data from the file, I will specify NA underscore values equals to that particular list we created. So wherever any of these values is read, it will be treated as a null value or a missing value, and it will be represented as nan. So this is what we are doing here, and if you see, all those values like question mark in the above is represented as nan. Nan actually got represented as nan. So this was a string, or you can say text nan. Now this is actually nan. Uh, this dash got nan, NA actually got converted into nan, unavailable got converted into nan. So whatever we have specified in these missing values list, all those things got converted into nan. Now this is all consistent, and if you want to find out how many missing columns are missing values are there in any respective column, we can use data.sna.sum. So what it will do, it will just calculate any missing values in each column and sum it up and give the result. So if you see in name there is no missing value, so for name the output is 0. For age there are two missing values for age, so output is 2. For gender no missing value, so 0. Location, all three are missing values, so location is 3. Let's say I'm just creating one more column, date of joining. Let's say these are the people who have joined an organization, and I'm creating a date of joining. So once it is created and it is added as a column in the data frame, so this is what it is. Now let's say I'm setting one particular value as nan. So data.ilog 0 comma 4. So 0 is 0th row and 4 is 0 1 2 3 fourth. This is the fourth index of column. So this gets set as null, and I'm just printing the data here. Now uh, now for the columns which are of date time type, in that case the missing value is represented as NAT. So this is different from nan, so it is not represented as nan, it is represented as NAT. So this is what I mentioned here. NAT is used to represent date time missing values. Now if I want to count the sum of the missing values in each column, I'll say data.sna.sum. So it will say for date of rest of the columns, it's same what we got earlier. Now for date of joining, we have we are getting one missing value NAT. So it's saying date of joining is 1. So there is one missing value in this particular column. Now let's say I'm creating another data frame which is having only one column data. Now there are some if we apply any mathematical operations on nan, we'll get the output as nan only. But if we apply aggregate functions, then what happens, those aggregate functions skip those any values. For example, let's say I'm trying to calculate the cumulative sum of this column. So it will do like this: 10, 10 plus 20 is 30, then 30 plus nan, again it will give nan, because 30 plus nan is, because we are adding nan to 30, so it will give output as nan only, but it will not lose out 30 what it had calculated up to here. So again, when the next 30 got added to it, it is giving the output as 60. So in a way, it actually skipped nan. So wherever nan was present will be represented as nan, and for rest of the values, it will apply those cumulative sum. Similarly, I can find out the maximum. So maximum, if I say, is 30. So again, nan was skipped, and we got the output. Now let's say how missing values behave when we are doing a group by. So I've just created a data frame in which we have one column as color, another column as price, and for different color there is a price mentioned. And for some of the rows there is nan coming. Okay, now what I'm doing is a group by on the basis of color and finding out the sum of the price. So df dot group by color, and selecting this column price and finding the sum. If you see, I'm getting output for all of these colors, so there is no nan coming in the output. So what it means, this group by has actually skipped the nan values and then calculated the sum. Just to quickly verify, for black it was only 30, that is fine, one record. For blue, two records, 15. Okay, only one record, 15, fine. Now for red, Okay, so black was nan, so that was so 30 plus nan. So it actually skipped it. So otherwise, what it would have done if it had taken nan into consideration, then for black it would have given us 30 plus nan as nan. But because this group by had skipped these nans, so for black it gave 30, for blue it gave 15, and for red it gave 10 plus 40 is 50. Again, this particular record was skipped because it is NaN, so group by skipped this and then calculated the sum for the remaining red colors. So, how do we deal with the missing values? We can impute it, or we can, let's say, drop it if we want to. So, let's say we have this data frame df, okay, the one that we calculated created above. Now, if I want to drop, then I can specify df, which is the data frame dot drop na, and then we can specify the condition how equals to any means if any value in that given row is missing or is nan, then drop that row. So how equals to any means, so in this case, this row red nan will be dropped and black nan will be dropped because we are getting at least one nan value in this particular row. So in the output you will see only those records are coming which do not have nan in any of the columns. Now another option is df.drop any and how equals to all. So a row will be dropped only if all the values are any. Let's say if we have a row in which color is also null and price is also null, then that particular row will be dropped. That because we are specifying here how equals to all. So it will check for all the values. So a row will be dropped only if all the values are null. Otherwise, it will retain the row. So that is why we are getting retain all the rows, because in all the rows we don't have any row in which all the values are null. Now we can impute it. Let's say if we want to impute the missing values with the mean value of the price, then we can just simply say df and the data frame, and the column is price, and I want to fill the any value. So I'll use the method fill na. Now, and within the bracket, I'll specify the value that should be used. So I want to find out the mean value of price. So this mean function will calculate the mean value of the price, and it will get imputed. So again, because mean is an aggregate function, so it will skip the existing nans, and based on the remaining ones, it will calculate the mean value, and so that will be imputed. So if you see this 23.75, this 23.75 is coming after the null values got replaced by the mean value. Now there is another method which is forward fill and back fill. So what forward fill means, if there is a value which is nan, then then the previous value will actually uh, f- replace that nan value. So if I say df.fill na method equals to ffill, which is forward fill, so the previous value will actually do the forward fill in the next in the nan value. So 30 will replace this nan. So if you see here, this 30 actually replaced nan, so this coming as 30, and 40 here is coming, and after and in forward to 40 is this nan, so it will do a forward fill. That is, this 40 will fill the will fill this nan which is coming forward to it. That is 40 will replace this nan, so that is why we are seeing forward fill. So opposite to it, we have another method called as backward fill, which is b fill. So again, what we have to do is say df dot fill na and method equals to b fill. So in this way, now in this case, if you see, because nan is the last uh, value in this particular data frame, so that will not get filled because we are choosing a backward fill. Okay, so it's like moving from the backward direction to upwards direction. So because there is nothing below this, so it did not get filled by anything, so it will remain as nan. Now this 40 is coming, is 40 fine. Now this is nan, so it will be filled by its backward values, which is 40. So this 40 will do a backward fill. So basically this 40 will fill 9 which is coming backwards to it. So this 40 will fill to 9. So that is why we are getting 40 here also. And above that there is no 9. So rest of the values are coming as it is. So these are the different methods in which we can fill the 9 values, either forward fill, backward fill, or we can impute it with some values like mean, median, and uh, and clear the data. So that's it for this tutorial. Thank you.